Okay, all right. What's up? So I'm reading this book, Material World. It's really good. It's really, really good. And the first section's on sand and the importance of sand in the semiconductor industry. So I want to do a little bit more research. What I'd like to do is because I always like to look at the places. I think it's just Google/Earth. I don't know. In any case, what I'd like to do at some point. Yeah, might as well. I don't even know what a project is, but I had this written down somewhere. We can do just a little bit of a tour. I want to do a lot more research and make the acyclic graph of all of this stuff a little bit broader. Okay, here we go. So the first place is Santiago de Compostela. It's actually Pico Sacro in Spain. So these guys, I guess, my understanding is that, and you can see this for some reason, this is so much slower than Google Maps. But if you zoom out, you will see a big ass quarry. Is that here's the quarry. So this is the quarry where basically chunks of quartz come out, and then it gets shipped. It gets transported up to. Oh God, I can't even do this. It's so slow. Okay, let's go to the different layer though. All right, so here, is this still that slow? No, see, this is fast. I don't get it. All right, anyways, it comes up to A Coruña, and somewhere in here um, there is a huge furnace basically, and the furnace, my understanding is, creates. Let's see. Let's refer to the text because I think it. Okay, so yeah, at this stage, after it is basically put into a furnace and then electrocuted, it it releases a lot of its impurities, and after Sabon, let's see, where is that? Sabon. Uh, Ferroglobe of its yeah. So okay, so it is Ferroglobe. I know it's that. Um, so just look up. Yeah. So we want to find the address of this plant. So let's look up Ferroglobe. It's got to be that. Oh, there it is. Holy shit. It's right on the coast? I mean, this has got to be it. Okay, so let's okay, so this is where they smelt down the quartz. If you were using sand, it wouldn't be blown up into the filter. It would be blown up into the filters and wouldn't melt. So you need large fist-sized lumps of quartz. So this is where the lumps of quartz get turned into silicon metal ingots, I guess, and then it's smashed up into granulated metal. So this is 98 to 99% pure. But then that goes to Whacker. So let's start to make I'll make a new little project here. So let's save, wait, I want it to be in order. So let's go back. So this is going to be picosacro, but particularly I want the mine. Here we go, mina cerebral. That's what we want. So we want to, yes, places to go. So this is a semiconductor supply chain. Okay, then it is taken to Ferroglobe, where it is turned into, wait, where's my list? What the hell? Wait, what? The hell? Why isn't that showing up then? There we go. Okay. Okay, so we have that. Now it is taken to Whacker, which makes polysilicon. So let's just get a look at what. So polycrystalline silicon. Right. So this is sort of the, I guess, so my understanding is that the vast majority of semiconductor production, it goes into like solar panels. Where you don't need nearly as high a purity. Okay, so let's find out where this place is. Whacker in Berghausen. So let's just look up Whacker Berghausen. So here's where the polysilicon is made. Whacker Berghausen. Whacker Chemie. Is it this? I'm pretty sure when I just went to Berghausen, you can't miss it. You literally can't miss it. Because you go here and there's this fucking massive city all devoted to this. So this is there. It's a city just I mean, I think they probably do other things, but probably a big part of what they do is just making polysilicon. So at this point, yeah, man, it's about as big as the city alongside it. That's crazy, and it really is. What an amazing place. I wish we had the 3D. We don't get the 3D view. Kind of wanted the 3D view. Okay, so at this point, okay, so solar grade polysilicon is 8 nines. And then there's monocrystalline solar grade polysilicon, which has 9 nines. And then, okay, so it says the vast majority of polysilicon goes towards solar panels, and the vast majority of that is made in China. However, they don't have semiconductor grade polysilicon, which has 10 nines. So that means that for every 10 billion silicon atoms, you have one atom of something else, which is insane. Okay, but it's still not there yet. Wait, but but it sounds like 10 nines is what you're after. I mean, it's mainly just because the yield. I mean, you are going to split it up and dice it into a small little chip. So, yeah, the bigger the chip, yeah. And purity isn't the only thing that matters. So too does structure. Yes, you need a perfect crystal. Bro, if I was a crystal girl, I would totally wear a little silicon ingot. Okay. So the next step goes to it says Portland, Oregon, but I actually found it's in Vancouver, Washington. Let's see. Can I find it? Um I think I looked up Shin Etsu Portland, but I think we want Vancouver. SEH America. And I'm pretty sure I could probably just find this. Look, MapQuest came up. That's crazy. So can we copy this? It doesn't even have the address for me. Okay, there we go. So let's just look up SEH America. There we go. Wait, is that right? So the Columbia River is there. Okay. So I don't know why it said outside of Portland. Oh, I guess it is outside of Portland. I didn't realize how close they were. So yes, so let's save this. So here is where some more magic sauce happens. Because after this, you get these super pure quartz crucibles. I'm going to get my jacket. I'm cold. All right, so if I wonder if I can turn on all of the points. But so where we've gone so far, and this is just the book. I kind of want to. Oh, here's all our saved. So it goes from Spain to Germany to Washington in America. Okay, and then the thing about this is, let's look up silicon boule. Yes, exactly. This is what I was this is what I was imagining in my mind. So this is the germanium. Well, we want silicon boule. Let's look at monocrystalline silicon boule. So you see though it's wavy on the sides. They must have to trim that or something. But yeah, they melt this in this crucible and then they pull it out and it becomes this. And then they slice that with I forget, how do they slice it? Silicon carbide wire saw. Silicon carbide wire saw. I wonder if we can go to I wonder what wire saw they use to cut it. Because if you want to cut your own wafers, you need to know that. All right. In any case, so you cut these and then you get a wafer out. So silicon. I can't believe I keep doing that. Wafer. All right, and so then you get one of the let's see, when it's just before it's there you go. So there's the bool, and then there's the result as you cut that up. And let's look at this CZ process. So this is the process that this Shin-Etsu company does. Is a method of crystal growth used to obtain single crystals of semiconductors. This is so cool. He dipped his pen. This is like one of my favorite things in this book because it's like, oh, I just love these happy accidents in history. When he dipped his pen into molten tin and then he pulled it out and then he got a freaking medal. Oh, that's so amazing. Didn't he die or something? Okay, and anyways, so this guy came up with this process for making these bools, I guess. So then after you have your wafers, oh, and that's the other thing is where is argon? Wait, let's get ChatGPT. How is argon gas manufactured? Or like, what is the supply chain there? Oh, so we can just make it? I thought argon was like rare. There's a ton of argon in the air. I mean, for the amount that we need it, I feel like argon's not a big deal. I thought argon was problem. I mean, obviously, it's probably a decently energy intensive. Yeah. Okay, cool. So yeah, so um yeah, so I do want to also do another one of these where we go into Chinese silicon production and where they do it. The thing is I feel like it's going to be much harder to find information about, but it would be interesting to know how China does it. Because this seems like the Western semiconductor supply chain so far. And then, of course, it's going to go back to what everyone knows about, which is TSMC. But there is another place that we would need to know, which is spruce pine. The Quartz Group, Sibelco. I think it's this. Ryan Airplane Company? Wait. They have their own freaking runway. That's so insane, dude. That's crazy. All right, so, well, that's what it is. Sibelco. Schoolhouse. It's rated a 4.5, everyone. Guys, we can eat there. We can eat at Sibelco. All right, so what these guys do is these guys help Shin-Etsu because they provide the ultra pure quartz crystal. The interesting thing is like basically what we want to do is we want to find all of the quartz mines, sort them by their volume, and then sort them by their purity. So we basically want to get a quartz map of the world. and we want to start figuring out where all the quartz is. Because you can get, let's go to Lachlan Mine. It's got to be that. Oh, there. It's got to be that. So these guys have ultra pure quartz sand. But remember, we just went over if you're gonna make polysilicon, it's not the CZ process, but it's the what is it called? I think maybe it's just, let's see. So we sort of want to get an idea of everyone that's involved in this. So there's this Norwegian company. Okay. But what is the... I guess there's no name for this process to turn quartz into silicon metal. In any case, you can't use this. This is used mostly for glass and other stuff like that. Did we save it, though? It's not really part of the semiconductor supply chain, but it's more part of the sand supply chain. It's more about where the pure sand is. I mean, we're just talking about geopolitical places of interest, honestly. And one interesting tidbit from this thing is, what is the... where are those... I think it's the book starts with this. The book starts with one of these, whatever. We can go into the glass part later, but glass is obviously, because the thing is, we want to also add ASML to this. So, okay, so anyways, the long story short is after Portland, after we're in Portland, we get shipped to... Oh, and Sibelco in North Carolina, that's not even an American company. That's a Belgian company. Oh, here's just a fun anecdote. According to one person who has done business with Sibelco, going to their headquarters is a bit like getting into Fort Knox. When contractors from other companies are brought in for repairs, they are literally blindfolded and marched into the factory up to the machine they need to fix. That's crazy, bro. Okay, anyways. So I'm sure someone has done this, but I don't know. I felt like this was fun for myself, just to get an idea of just how... I mean, I would love to generate these. I would love to, like, make a little tool where you could name a product, like a pencil, and it would generate, you know, a map of all of the things that need to come together. And you just start to draw maps of all these products and how all this international coordination happens just to make a freaking pencil. Okay. Our silicon, which began its life on the side of a Galatian mountain, has been through numerous transformations from solid to liquid to solid to vapor to solid to liquid to solid again. That's crazy. Solid to liquid to solid to vapor to solid to liquid and to solid again. Wow, that's such a hype freaking line. Now finds itself inside a sealed canister on the other side of the world. So now we're on Tainan. So I'm pretty sure I can just go to Taiwan is where? Taiwan's here. Okay, so that's... So let's just go to Tainan. Oh, what? It just says the old capital of Taiwan. Okay. On the outskirts. So let's just look for let's see, do we get 3D? Fuck, how do I do this 3D thing? I could have sworn there was a 3D view that if I just shift, let's just go to Boston really quickly. If I zoom into freaking Boston. So, okay, so it's not shift anymore. What the hell is it, though? Is it alt? How do you get the 3D? Oh, you know what I think it might have been? I think if you do this and then you zoom out. What? Fuck. How do you get the 3D? Let's try it in maps. Just really quickly. Somehow Google Earth is like the slowest website ever. There we go. That's hype. I mean, this is one of the coolest things ever. A 3D freaking reconstruction of the entire world. Give me a break, guys. Okay, so we want to go to Tainan. TSMC. Yeah, Fab 18. There it is. That's what it is. Holy hell. Now that's a freaking factory, bro. All right, so let's just go to Fab 18 in there, and we'll do the 3D if I need to. They got fast food there? What is that? Is that a lake? In any case, let's save that. It's only got a 3.6. Guys, who is dunking on TSMC's fab capabilities? That is crazy. Applied Materials is there. I mean, this is really an international, global, coordinated effort to freaking make semiconductors. And I mean, technically, that's the end of it, right? But I guess where does ASML manufacture their stuff? That's kind of what I want to know. Because, all right, so let's close this out. We have places all over the world, but it's really not that many because we need to go to Denmark. Okay, so let me just make a list of things to do. Map every quartz mine and rank by purity and volume. So let's just ask ChatGPT. Biggest quartz deposits in the world. Oh, wow. Spruce pine. There you go. Number 1. Okay, so Russia has some. Okay, see, the thing is, you always have to take ChatGPT a little bit. I mean, you just got to think about what's in its training set, and there's just a huge rift between the West and China in terms of information transfer. So it's likely that this is like debiased. Like this is lower on deposits in China are less well known about to ChatGPT than they might actually be in practice. But in any case, this is probably from someone that has done research. So let's look at this. So wait, make a table with like volume and purity. What about in Spain? Oh, dude, I want to make graphs, bro. I want to make graphs so bad. Test your intuition. Dude, that sounds fun. Why is this still loading? Dude, yeah. I've always wanted to do stuff where I study trade data. They got a chat OEC? That's fucking sick, bro. Whoa, how much petroleum were the top exporters of bananas in 2020? Oh, that's so sick, bro. Oh, trade data is so interesting. Where do they get this from? Is this thing ever going to work? There you go. Dude, yeah, I want to play these games. These games about guess the 5 countries that export the most coal briquettes. And they have a name for it. What is this? Oh, tariff classification of coal briquettes. So interesting, dude. The material world is so interesting. Okay, in any case, what was it though? What about the silicon metal exported from A Coruña and mined in what was the place? What was this called? Santiago de Compostela. Let's just say Mina Cerebral. So okay, so you can't just wait. Let's go to the OEC and let's just look up quartz. Right, but then let's look up silicon. Okay, so we're gonna want to look at that for sure. But let's just look at quartz. Because quartz is the start of it all. But let's see if this lines up with what we... Oh, shit. It's not only the top exporter, but it's the top importer as well. Can we get a map? So the thing is, I guess the question is, what else is quartz used for? So wait, what is this? This is exporters, importers. So what is quartz used for? Right. Okay. So right. Okay. So the thing is, though, we have to try to. So let's go to this. Okay. So the top exporter of high grade silicon is Germany. So maybe that's Wacker. And then the top importer is China. So we export high grade silicon and we don't import it. So we have domestic high grade. I mean, the thing is, in 2022 was the 651st most traded product. How do I get, dude? I want to know what the most traded product was. Let's see if this works. I kind of want to look at networks though. Dude, oh, I would work on this, bro. This is like interesting stuff. Wait, wait, let's go to chat. Oh, that's so fucking awesome. Graph theory, bro. I love graph theory. Okay, so wait, let's go to this chat thing because I just want to ask what is the most traded item for 2022? Sure. Whoa, really? Wait, okay, wait. If we go to that search. Okay, so it said, okay, so quartz was, I don't know why it's saying out of 1,200. But let's go to so the search. Where's the search? I think it's just this, right? So this should say number product complexity. See, what are all of these? Oh, dude, product complexity. That's so fucking cool, man. Oh my gosh. Studying trade like this is so interesting, bro. Wait, relatedness versus country. I don't even know what this is. Compares the risk and strategic value of a product's. Oh my gosh, dude. This is like I can't believe I didn't know about this. This is like the coolest thing ever. Dude, there's so much research in this. Was the third most traded product. That's crazy that it goes soybeans, integrated circuits. That's insane. That's actually crazy. Wow. But so China has domestic production, and the United States does not produce any integrated circuits. That's crazy. I wonder if we can go back in time. I have to imagine that we were number one up until like maybe the 80s or something, maybe even beyond that. But I have to imagine that the US at one time was the leader. Okay, so um, this is the crucibles. We know that. But okay, let me just ask ChatGPT what it. It keeps saying spruce pine, but does spruce pine just make the crucibles? Because it just keeps saying the crucibles. I feel like it's like bullshitting me, bro. This is that carbothermal reduction. Electric arc furnace, yeah. Metallurgical grade silicon. This is exactly what we just went over. And then electronic grade silicon. And then it's distilled. 9 or 10N. That's crazy, bro. It's funny how, like, no matter where you go, you can always sort of get a gauge for how difficult something is just based on the scale. Like, in this machining class, you need to machine something to, you know, what they would say is really 3 nines. I mean, it's on the order of 3 nines. It's a little bit wider than that, but it's there. But then imagine going to 10 nines on something. It's just crazy. Right, and so then it makes the ingots using the CZ process. And then it's sliced up, and then it does the fabrication. And then this whole thing. Okay, so I think I'm ready to read this strategic thing. We sort of have the map, but we want to know, I mean, we want to know all the ASML stuff. Like, where does ASML actually have a factory? I mean, I'm kind of distracted by how sick this OEC thing is. Product complexity? Okay, the complexity relatedness diagram compares the risk and strategic value of a product's potential export opportunities. Relatedness is predictive of the probability that a country increases its export in a complexity is associated with higher levels of income economic. So I don't quite understand this diagram. So it's saying that it's super likely that China is going to increase its exports in semiconductors, and it's a high risk thing. So on this scale, for each country you have, like for the United States, it is a high risk thing, but it's not, we are not like increasing our specialization in it in the sense that we are not going to produce it. Or rather, we're sort of in the higher end of producing it, but like compared to Germany, Japan, China, interestingly, Italy, this seems like an outlier. I don't know, what does the size of the dot actually mean? The size of the dot is its exports. That's got to be what it is. Because all of these guys, like Mali, Guinea. Dude, what? I would like to study Mali's exports of integrated circuits. What integrated circuit? Not to diss them, but if you're exporting $200,000 worth of a product, it's a super small industry. So I'd just be curious, what is this attributable to? Because that it just seems like an interesting thing that some of these, like all of these countries that export a few $1 million worth of integrated circuits, it's like they got some homegrown fabs, bro. Top export potential, top import potential. So Vietnam is likely to import and India is likely to export. Okay, so we want to get all the quartz mines, but we also want to get all of the fabs in the world and sort those by. All right, but let's just start reading because I feel like I'm capping out on how much I'm learning from this. I do want to study this trade data though. So what does green mean? Green means it's a net exporter. Let's look at Taiwan. So Taiwan is also an exporter. It's interesting that China is, but they're barely, I mean, given the size of their market, $500 billion. Now look at that, dude. India exports literally no semiconductors. I don't know what the hell India is doing, man. Get on that. That is a total joke, man. France actually exports. So, okay, this is what I don't understand. Is to be considered an exporter of integrated circuits, what does that actually mean? Right? Like, this is the sort of problem with supply chains is like, does it literally mean that they are fabbing their own integrated circuits? Is like France actually? Oh, there you go. Dude, the OEC is so fucking cool, man. Oh, see, I mean, there's just so much interesting information here. France exported 10 billion in ICs, and it was the 14th larger of it. It was also their 13th most exported product. So wait, let's just go to France. The main destination for ICs is mostly other European countries. So there's like a distance friction maybe, but I don't know how much you could actually attribute to that. Like, do they have a fab? I don't even understand. Wait, Hong Kong? See, no, the fact that a country exports ICs does not necessarily mean it has fabs. See, they import and export, but you got to normalize that out. Like, who is actually making them? That's the question that you're actually after, right? They package and test them, and then they re-export them. So they're hubs. So you have to normalize that out. Back end operations. Oh, interesting. Well, but you do want to know the people that do that too. But it's like a separate operation. That's the problem. Is you have to get a better granular sense of like what. But just because you designed it doesn't mean you could be considered to export it. That doesn't make any sense. So this is like the. So this is like the general thing is like. So, but the thing is, how do you measure who designs them? I still don't have a sense of scale because, like, okay, this book makes it sound like Fab 18 is like a super complicated process, and it's like let's just go to Fab 18, F18. It was right there. So, but they don't give me a sense of scale of like the volume of wafers going into this. Because if TSMC makes all of Apple's chips, then they have got to be going hella fast. So it's not just like it's like this slow like it says each wafer takes months to make, but it's not like it's just being, carried around by some, donkey. It's got to be moving fast. I wonder if we can get a video. Let's see. Can we get a video inside of an operating fab? Operating semiconductor fabrication plant. I don't know. Can we, like, here we go. So, is this probably old? Is this video gonna, yeah, obviously you're not gonna show me any pictures of an actual. So fucking awesome. So cool, man. So anyways, all right, so let's read this thing that's like actually in depth. It's pretty long, but I feel like it's worth it if you want to understand what's going on. So I'll just read it out loud. Why not? Today, the word semiconductors most commonly refers to integrated circuits, and the semiconductor industry is among the most critical sectors of the global economy. Annual sales of semiconductors are large, more than $500 billion in 2022. And that actually, so, okay, so as someone that's not an economist, it's interesting trying to actually think about what that means, right? Because when you quantify sales, are you doing what I would imagine is you, at some point you draw the line and you say, okay, this is where it's sold, and then you discount everything before that. So you would basically, in this list of things, goes from United States to Taiwan to Vietnam and Malaysia to Singapore. You're counting the sales of the distribution of it, and you're discounting all of this sale because that's all included in this, and this is where you get the biggest number. But I don't know if that's actually how it's done, but I have to imagine that you're basically saying at the distribution point, at the sort of the end user, because but that's before the iPhone, but after Fab, obviously. So this is so that the sale of it would be like Apple purchases their chip from a distributor in Hong Kong or something like that, and that's the number that is contributing to this $500 billion. But I don't know if that's how it actually works. We'd have to really get into economics or something. More importantly, however, the semiconductor industry is an irreplaceable enabler of tens of millions of dollars of annual economic activity worldwide. Tens of trillions, right? Enabler of tens of trillions of dollars of annual economic activity. Semiconductors are not only found in data centers, laptops, and mobile phones, but in automobiles, washing machines, light bulbs, nuclear missile guidance systems, electrical grid infrastructure. In the United States, semiconductors account for only 0.3% of GDP, but they're an important production input to 12% of GDP. See, and this is one of these things, I always talk about this, but there are special words that you have to keep your eye out when you're reading something new. Production input is clearly a well-defined term. If I were to Google this, this is a term that's been thought about, is all I'm trying to say. The importance of semiconductors is best demonstrated by the drastic economic consequences of the recent semiconductor shortage. This was written in 2023, I believe. Yeah, May of 2023. Analysis by the Department of Commerce found that the chip shortage shaved an estimated $240 billion off of U.S. GDP. Now that's crazy. That's crazy. The auto industry alone produced 7.7 million fewer cars. Yeah, can we go? Okay, wait. So let's start to close some of this extra stuff. So, yeah. Okay, so we do want this open. And I want to look at cars. I just want to, type in cars. Here we go, cars. Okay, so cars account for about... So, okay, this is what we have to figure out. It's because, I don't really know what that means. But in any case, I also want to know about product complexity. Can we figure that out? What is product complexity? I mean, it's clearly a graph theory thing, right? I guess there's no Wikipedia article on it. The Atlas of Economic Development requires the accumulation of productive knowledge and its use in both more and more complex industries. Harvard's Growth Lab's country rankings assess the current state of a country's productive knowledge. No, but I think this is a different thing because, yeah, we're talking about product complexity, though. Anyways, I would like to know what how product complexity is, because I have to imagine that a really complicated product requires coordination from many different places or requires a lot of operations. So either the graph traversal from, at some point you have, I'm sure there's all sort of ways you can game this, but if you just look at let's just say we started with the quartz, the raw quartz, that gets melted down. If you count how many operations it takes before the product happen, yeah, it's some sort of edge counting thing. It's got to be. I don't know. There's probably other factors to it, but I would imagine it's some sort of. Okay, so wait. I also love this classification thing. So what's the most complex? What's the most complex product? Is this thing gonna load, dude? Search for product. I want to know all the products. Oh, there you go. Okay, wait, hold on. That's the formula. Ranks the diversity and sophistication of the productive know-how. Yeah, ranks the diversity and sophistication of the productive know-how required to produce a product. PCI is calculated based on how many other countries can produce the product and the economic complexity of those countries. Oh, that's a weird coupling that I wouldn't really. Let's read it again. PCI is calculated based on how many other countries can produce the product and the economic. So it's all based on countries then, and the economic complexity. So then country economic complexity is used in product complexity, which I don't really think is a good way to do it. I don't really think that makes a lot of sense because a country specialized in doing something of high technical value. Well, I don't know. Maybe in practice it works because there's going to be outliers, but for the vast majority of cases, if you are a technical country, then you have the means to do it. I'm just thinking about countries that are like highly specialized that may have a low economic complexity, a low country economic complexity, but export one specific product of high economic complexity. In reality, I feel like that happens rarely. So maybe this is okay. In effect, PCI captures the amount and sophistication of know-how required to produce a product. Okay. Oh, here's a paper on it. For Adam Smith, wealth was related to the division of labor. As people and firms specialize in different activities, economic efficiency increases, suggesting that development is associated with an increase in the number of individual activities and with the complexity that emerges from the interactions between them. Here we develop a view of economic growth and development that gives a central role to the complexity of a country's economy by interpreting trade data as a bipartite network in which countries are connected to the products they export. You need another import graph, though. All right, so we need two bipartite graphs. That's what we need. We need an import graph, so GI, and an export graph, GE. And these are both bipartite. And once we have that, but then the thing is you need that. Yeah, so that's all you need. And let's say we have 10,000, we have 200 countries, and we have whatever, 10,000 products. That's probably good enough for our sake. It would be interesting if we could recreate this, if we could download the data and we could recreate the economic complexity charts. I gotta pee though. Okay. So I want to look at on the OEC. Oh yeah, interesting. Soybean. So food, compute, and energy. Wow, vaccines. I feel like that's and then cars. Interesting, man. Uh, what are the most complex products? So wait, but did this tell me how? Okay, wait, we didn't really get this. Product space. Okay, but I also want to search up. So wait, let's go back to. We'll wait for that. I want to look up a really specialized product. Gene sequencer. This is going to have no results, I'm guessing. So, but that's what I'm getting to is that there's a garbage in, garbage out. Whoa! A couple of whoa! A couple of F-18s just flew above me, bro. I was like, those are flying low. Someone's about to get freaking murked. Someone's about to get taken out. That was crazy. Right above me, man. All right. I don't know if you guys heard that because I had the noise reducer off. Anyways, so there's a garbage in, garbage out. What if we look for PCR machine? Polymerase chain reaction. Because what I'm trying to get at is who's ever doing the aggregation, who's ever classifying products, is doing a, I mean, it's like, they're making a decision on, and it's just a consequential decision on how you can interpret this data, because like everything is unique, but at some point you have to have a principled way of writing down these commodities. So anyways, we need to, so this HS system, that's what I want to know about. Harmonized system. For 2-digit? Yes, I remember this thing. Okay, so let's just look at this. Harmonized tariff schedule, basic publication, and this is still in use. Is there no introduction? Oh, this is all legalese, bro. I don't have the time to read this. So we got, okay, so product 1, live animals, meat, fish, dairy, trees. Okay, vegetable products, prepared food, mineral products, salt, that's interesting. Ores, fuels, chemicals, plastics and rubber, hides, textiles, footwear. God, the classification of this is so interesting, man. Metals, machinery. See, look at this. See how broad of a classification this is? Electrical machinery and equipment and parts thereof. Sound recorders, television image, and part. Okay, yeah. See, I mean, this was written in 1992. They had no idea what was coming. I mean, can we get a graph of cell phone adoption? Not smartphone, cell phone, just mobile phone. I guess it's that. No, we want it before that, bro. Yeah, we want this. So yeah, in 1992, basically no one was using a phone. Okay, vehicles. Oh yeah, the two code is vehicles, right? So okay, so we're starting to understand how this OEC is categorized because in did I already go away from it? 87 was this. So wait, if I go to the OEC and just look for who exports the most trains, and I just search for 86, let's see what shows up. There we go, railway and trams. It's a pretty small industry. Rank, oh yeah, see, that's what I want to know. Is out of the two, oh yeah, okay, so out of the two, HS2, rank by money. Yeah, because this is like pretty low down. But who is the exporter? Let's see. China, obviously. The United States, I guess, makes trains. Germany kind of expected that. Didn't really expect Poland and Austria, but I really never think about Poland and Austria, honestly. To my own detriment, but I'm just saying I don't, I kind of lump all of Europe together, I guess. They should just join. They should just join, They should just all merge. Become one giant bureaucracy. Okay. So what am I doing now? I kind of want those two bipartite graphs, but I know that it's going to be annoying to I mean, this group OEC has done a lot of work. And then it became a product. That's so cool, man. Dude, the OEC is fucking awesome, bro. The Observatory of Economic Complexity. I love this website. For me, this is actually up there with Wikipedia and OpenStreetMaps. Yeah, dude, the OEC, bro. Heck yeah. And they make games and stuff. What a fun thing, man. Cool. Let's see, where is it at now? Subnational data. It's so weird that this was published in an AI journal. That doesn't even make sense. But, whatever. Okay, yeah, we're reading this thing. That's what we're doing. So, in other words, U.S. GDP was a full 1% lower than it would have otherwise been had the semiconductor shortage never occurred. For comparison, the average U.S. GDP annual growth rate over the past 10 years has been 2%. So, yeah, that was a huge hit. Okay, wait. Is there a difference between if I search up semiconductor on here, is that a different classification? I mean, trade is about networks. Trade is fundamentally a graph theory thing, but I'm going to keep talking about it because I love graphs. They got the harmonized system. I wonder if this is a standard or if, I mean, I'm sure they have to do a cross-country classification thing because I'm sure that everyone's tax codes are different. And I mean, this all comes down to taxes, the oppression of the people with taxes. That's always what it comes back to. But so then why is the US here? Okay, first off, this is clearly this graph looks wrong, dude. Why is it saying million? Oh, wait, this is just a what? Anyways, that's a bad chart. A value chain, dude, I'm just straight learning economics, bro. A value chain describes the set of processes that are performed in order to transform the economic inputs into outputs. Each link in a value chain represents a supplier-customer relationship, whether internally within an organization or between different organizations. In the case of a semiconductor industry, the global supply chain that enables the aforementioned technological process is remarkably complex. Some companies play a diverse set of roles, others are highly specialized. But no single company and no single country is currently capable of internally performing all roles in the supply chain for all types of semiconductors required for a modern economy. It's kind of a moot point, but it does give me some good definitions. So I'm going to write down value chain. Value chain is the way that it's framed as a supplier customer relationship. And I'm going to say edge. I'm going to say edge to make it more graph-like. Individual integrated circuit chips with millions or even billions of transistors squeezed onto a square inch or less of silicon underpin nearly all facets of contemporary technology. The intricacy of semiconductors extends to their production process, which takes 4 to 6 months and involves more than 500 discrete stages, ranging from specialized design software to fabrication plants and dedicated test facilities. Consequently, the semiconductor supply chain is remarkably complex, segmented, and international. According to estimates by Accenture, a consulting firm, the various inputs to a typical IC chip must cross more than 70 international borders before a final product can be delivered to consumers. I don't really know. What does this even mean? What does that even mean? If you fly over a country, does that count? I'll just run my product around the world a few times and then say it crossed a bunch of borders. I don't know what that even means. Accenture. Leading chip sellers routinely have tens of thousands of suppliers distributed around the world. So I'm curious, who actually assembles the packaged product? Like, so the designer, Apple, so Apple works with TSMC. Okay. But TSMC works with someone in Vietnam or Vietnam. That works with someone in Singapore. Or something like that. So we need to figure out who those companies are. Leading chip sellers routinely have tens of thousands of suppliers. Suppliers. So the chip sellers are the customer in that edge. So the inputs to those chip sellers are diverse, is what it's saying. And some suppliers are the only companies in the world that possess their technological capabilities at specific performance levels. Understanding the structure of the global semiconductor manufacturing landscape is critical for policymakers as they aim to navigate shifting supply chains. I wonder how many people in Congress read this. Probably none. Maybe a few. I feel like there's probably a few people that are interested in this that are in Congress. So here's a depiction of the value chain. Okay, so this is a value chain. There you go. A high-level value chain. Software and IP into a design. Yeah. So what they're saying is that the inputs to the fabrication, because they're the seller, right? And they assemble and test. And you know what doesn't really make sense to me? Why would TSMC not assemble and test themselves? I'm going to write that down. Because TSMC needs to test their own shit anyways, right? So it's like, I don't know. Seems a little... Okay, anyways, let's get into design. The semiconductor manufacturing process begins in design. See, okay, this is the interesting thing about taking a graph and writing a story about the graph, is because they're starting at design, whereas material world starts at raw ingot, or raw rocks, basically. Where a blueprint of a chip's architecture is sketched out to optimize for certain parameters, including cost, power consumption, and capacity, based on the needs of the chip in question. Originally, the chip designs were hand-drawn, but as the number of transistors on a single semiconductor grew to hundreds of thousands and billions, highly specialized software became necessary to manage the resulting set of complex interactions and layers. Certain portions of a chip's design are built using reusable pieces of intellectual property called core IP that firms license to lessen the burden of the design process. The design segment includes pre-competitive research, design automation software known as EDA, and core IP. So we run the software game, sort of. Is there an open source synopsis or cadence or whatever? I think there is, right? So the United States leads in the semiconductor design segment, with U.S. firms capturing more than 40% of a global IC design market share. So EDA, semiconductor IP, and design services. Oh, what? Whoa. Wait. Schrodinger makes EDA software? No. I don't know. Yeah, so Altium. This is more PCB, right? So, but I don't know a lot of these companies. I mean, I know Cadence, I know Ansys, Synopsys. Schrodinger, I thought was molecular dynamics, but I guess maybe they have some role in it. You know what? You know what would be interesting? You take a value chain, you divide the edge weight, edge weight, and you divide it by the sum over the whole value chain. And then you could say how critical is that piece to it in a way. I'm sure someone's done that. I'm sure there's a name for it even. Because if semiconductors are 500 billion, then this 8 billion is like pretty small comparatively. Or is it the sum of the value chain, or is it the last leg of the value chain? Because you would expect that value chains are monotonic. I don't know. I don't know how all this stuff works. Right. So then what is it considered the diff of a value chain? If you subtract its input and its output, then you have to have somewhat, I mean, everything has an output, and then a value chain is just like a subgraph that's acyclic. Acyclic and has an end node. It has an end node. So maybe a value chain is a DAG with an end node. One end node, I don't know. Maybe, maybe not. Oh, interesting. So the U.S. is trying to hamper Chinese access to this design software. The thing about software, bro, is I don't know. I mean, that's interesting. So in March 2023, Huawei has EDA tools for designing chips at 14 nanometers. All right, this is what I'm curious about. Fabrication, materials and chemicals. Raw and manufactured product materials such as silicon wafers, photomasks, and photoresists, along with certain chemicals, are necessary inputs across the semiconductor manufacturing process. The market for materials exceeded 40 billion, which is, 5 times that of the software. Is concentrated in the United States, Germany, Japan, Taiwan, South Korea, and China. Taiwan leads with a quarter of global materials market share by sales. Wait, so they sell the materials? Where are they importing them from? That's a interesting footnote. Or not footnote, but that's an interesting thing to think about, right? Oh, there's hella birds above me. Let's move our operation before we face the wrath. All right. All right, so all good, I guess. All right, so we've avoided the crows. All right, so this says in 2021, Taiwan captured the largest slice of the market for uh, semiconductor manufacturing materials, with a quarter of global materials market share by sales. Europe occupies a critical space in the materials supply chain for chemicals. Low-grade gallium, tungsten, and magnesium. I mean, I really don't know what goes into manufacturing all this stuff, so I don't even know why gallium, tungsten, and magnesium are important. Okay, so Taiwan. Silicon on insulator. I don't. Photo. Okay, so wait, let's just read through these materials. Other CMP slurries and pads. I don't know what that is. Sputtering targets. I also don't really know what that is. I know what sputtering is, but I just don't know how it plays a role. Wet chemicals. So wet chemicals. Let's look at Europe. Europe's not even in this. Interesting. Electronic gases. Photoresist ancillary. What does ancillary mean? Oh, yeah, okay. Associated. Photomasks, silicon photoresist. Okay. So silicon wafers make up the largest portion of the materials market. And a third of total semiconductor material sales. So the wafer suppliers have concentrated and from more than 20 to 5 with 95%. 300 millimeter wafers are the standard. So Shin-Etsu is the leader with 30%. So they make the wafers. So I guess, yeah, so Shin-Etsu actually cuts it. I wonder how they get stored and packaged. Because you got to make sure that they don't break on the way. I'm sure they're shipped by boat. I can't imagine they're flown. So do the Chinese not make wafers? No, the Chinese. See, all of this stuff is like China is quickly growing it. I mean, it's a huge risk and unknown of how. Did you guys see that China just unveiled a 500 qubit quantum computer? I saw that somewhere. I haven't looked into that. I wonder if you can make a boule out of like metallurgical silicon. I mean, yeah, it's not. You can't make a good wafer, but maybe you could get a few. Can we look at the cost of wafers? Where can I buy them? Wafer Pro. There you go. Dude, you only get one of them, right? Wait, for how many pieces? One notch? I guess it's 75 per thing, right? So if I add this to my, oh wait, okay, let's make an order. Prime, p-type, boron, yeah, this crystal orientation, resistivity 125, thickness this, double side polished, yeah, and let's get that. Oh wait, no, wait, yeah, okay, fine. All right, so this probably means per piece, right? So then if I go to my cart, it should say that I have to spend like, yeah, like $2,000 to get my wafers. But honestly, dude, if you want to just like get some wafers, because the thing is, a single wafer, it's not that expensive. You'd expect it to be more expensive, but it's not. I mean, $95 for a, I mean, if you pay the premium of not buying 25 of them, probably $150 for a wafer. It's not like crazy or anything. So let's go back to the article. Fabrication facilities print integrated circuits by layering transistor elements onto raw silicon wafers. Doing so requires extensive control over the process with highly specialized and sensitive equipment. The degree of precision required by semiconductor fabs is the most demanding of any manufacturing industry worldwide. Semiconductor manufacturing equipment that facilitates the precision, scale, speed, purity, and dependability required to sustainably produce semiconductors is expensive and extremely difficult to make. Supply is highly concentrated in key companies. Wafer fabrication as well as assembly. Equipment suppliers headquartered in Indo-Pacific countries capture 77% of the global SME market share by sales. All right, compared to the, I mean, this is a big agglomeration of a whole bunch of crap. So, okay. Uh, it's curious why they don't talk about the. Okay, so ASML comes up. Okay, so let's keep reading because they do get to it, but it's like it's a small point, and it's I think maybe it's a little bit over. I don't know. So the U.S. leads in wafer fab and packaging. Japan leads in assembly and test. Wait, what? I don't understand. Right, that's the other thing about these graphs is that they're often two-way relationships. So there's a coupling and not those directed edges are not as directed as you assume. Support and maintenance. Oh, I love that. That's fun. An interactive Sankey diagram. Me likey. Oh, me likey. Oh, Sankey. Oh. Okay. Um, so that's the interesting thing is these semiconductor manufacturing equipment sales are largely domestic. I wonder if you can. I wonder how important that is because it's a feedback loop thing, right? It's like if you're selling all your precise equipment to people around the world, they're going to try to reverse engineer it when problems arise, or at least learn how to fix it and they can make a better one. But if you're selling it to only people inside your country, then you sort of accumulate, if you know, depending on how. The trade game, dude, are there any video games where you have to do trade gaming? Like, it would be very fun to run America and try to, like, manage trade policy. What is wafer fabrication? Grow field oxide. Wait, why are there two sets here? Oh my God. This diagram is so freaking good. Grow an oxide, etch the oxide, diffuse some N-type, etch the oxide again, grow more oxide, deposit polysilicon. I don't know why you do that. How does that work? So, after China, South Korea, and Taiwan are the next largest importers. Japan is a major producer of microlithography and masking equipment, etching and cleaning tools, and deposition and related tools. ASML is the sole provider of the latest generation of photolithography scanner equipment. Nikon and Canon provide non-EUV photolithography stepper and scanner equipment. So Japan makes a lot of. So if you want a bigger feature size, like let's say you don't need super small cutting edge transistors, then you can go to Japan to get your stuff done. The thing is, I mean, look, like literally everybody is trying to reverse engineer ASML's EUV uh, stepper. Okay, assembly and test and packaging. I don't know anything about this. So ATP assembly, test, and packaging is generally less capital intensive than wafer fab. A wafer fab is 90 billion. Okay. Japan is the largest supplier of assembly equipment. So what is that? Can we look at semiconductor assembly, test, and packaging?
Through the previous episodes, we've learned about the semiconductor manufacturing
Yeah, that wire bonding stuff is really precise.
Substrates with metal or flip chip, where the circuits of the chip and substrate are connected.
Oh yeah, but nobody uses wire bonding, right? It's all the ball method.
Integrated circuit for elements such as high temperatures and high humidity.
Cool. So China knows how to do that. That's fine. I like that they make these strategic notes of like, okay, they're compromised, type of thing. Yeah, you guys can hear that. That's crazy, bro. There's so many crows. Um, yeah, I mean, what goes into actually like, so, okay, say you want, baby wants to build a fab. What do you fucking do? That's the question. Oh, okay, wow. There's 1,000. There's 1,500 confirmed wafer fabrication facilities worldwide. See, I would like to make a map of all of those places, and then wow. So they've already made 28 new fabs. I don't know if they actually hit that number, but the thing is, I advanced like what? Obviously, you have a faster chip, but I think maybe we're trying to cope and say, oh well, we still have the most advanced node, but it doesn't really matter. Dude, the freaking crow parade is here, man. I mean, it's obviously true that legacy chips are sufficient and due to cost complexity preferred for some applications in like automotive. Because the thing is, what are you gonna throw away the old fab? No, you're still gonna make stuff on them. HPC, quantum, AI. Oh, they're saying advanced node is 16 nanometers or smaller. I didn't know this. Wafer diameter size is a rough proxy for the technological sophistication of a given production facility. There's so many of them. The number of fabs in a given country is generally a poor measure. Each fab varies greatly. Effectively indexing the production capacity of each fab is difficult to assess with confidence. So this paper uses a number of facilities as an imperfect proxy for capacity. All right, what else is in this thing, man? All right, so we're at the end. Look, 50 billion has been allocated for growing U.S. semiconductor manufacturing capacity. Yeah, so there's a lot of work being done here. Anyways, I just wanted to make this little map for you guys. So if you want to get just a general idea of the steps that, I mean, honestly, this map makes it seem more simple than it is because it's only sort of like one possible path in the value chain. But so you mine quartz in Cerebral or whatever, then you smelt it down to metallurgical grade silicon. Then you ship it over to Wacker in Berghausen, and they process it into high purity silicon. But that's still not enough. So you send it over to Shin-Etsu, and they make it really pure, and they use these guys' crucibles in this very secretive quartz mine. And then you finally send it over here, but then you send it either over to, somewhere in Vietnam or something where they do assembly tests and whatever. So there's somewhere in Vietnam that they test it, and then it goes to Hong Kong. And then it finally gets shipped over to to whatever, uh, I don't know, the major ports of the United States, and then it finally gets delivered to your hand where you can watch furry hentai porn. And that's basically the supply chain. So wait, there was a complimentary article about this. Okay, so this is more of a policy paper rather than a background paper. I guess maybe I could look at some of the finance stuff. I mean, let's look at the CHIPS Act. We just look at this, and is there a link to the? Here you go, the GovInfo. Here's the actual. Whoa, it's just a freaking. Okay, let's get a PDF. It's 400 pages. Oh, there's a lot of stuff in here. I need to go to the bathroom. But let's go back to the article. So we're gonna read this, I guess. Get a real full, then it'll be a 3-hour lecture where you now know the general idea of the economics of the semiconductor trade. And we got to learn some, economics, I feel like. Okay. All right. So, securing the semiconductor supply chain. A seismic shift in trade, economic, and technology competition policy is underway in the U.S. Traditionally relegated to national security, increasingly bleed over into economic policy. Parallel to this shift is a U.S. movement away from traditional free trade agreements centered on market access and tariff liberalization. These are a lot of words I don't know. This is really an economics thing. Centered on market access and tariff liberalization in favor of arrangements focused on sustainability and worker-centric goals without offering additional market access. I honestly, this sentence is a total wash to me. I don't even know. These two moves have become part of a new industrial policy that aims to strengthen U.S. high-tech competitiveness while preventing foreign adversaries from acquiring advanced technologies. Under the Biden administration, the shift toward a more expansive definition of national security in trade policies, evident in the October 7 Bureau of Industry Export Controls on advanced semiconductor chips and the tools used to manufacture them. These controls include extraterritorial application of U.S. law on foreign supply chains and businesses that will significantly affect foreign firms. An emerging deal among the U.S., the Netherlands, and Japan to support the October 7th controls makes clear the United States is pursuing policies that restrain Chinese technological advancements while building more secure supply chains among the U.S. allies. In August of 2022, Congress passed the historic CHIPS Act, which provided, among other funding, $52 billion for the semiconductor industry. Onlookers have described this as a renewal of industrial policy in the U.S. Coinciding with this new approach to techno-industrialism is the pursuit of new economic arrangements. It's kind of interesting. I mean, if you take the view that the United States is a late-stage empire, then I feel like this sort of checks out. It's like you start guarding what you think is yours, but it's the cat's out of the bag anyway. I don't know. But it's like if you weren't to do anything and just leave capitalism to it, then we are going to lose it because we're all weak and soft in America. So it's like, I mean, but once you're weak, fat, and lazy, you don't suddenly get it back by imposing regulation or, these handouts. That's not going to work. But anyways, I guess we have to try. I mean, the real thing is whether or not China has a free economy enough to, I don't know. All this is full of exceptions, and, how it plays out is not determined. Chip 4. Why is Australia in there, bro? Australia doesn't do anything. Does Australia have any minerals? Let's go to the OEC and let's see what the hell does Australia even do, man? No way, it's called Tradle? Dude, we should play Tradle. Okay, so yeah, so they just they're a raw materials country. They're basically pillaging their land. They don't really do anything else. What is the high tech in Australia even consist of? See, that said though, there's a good number of YouTubers that do cool ass shit in Australia. So it's still a Western, it's still a Western country and they do cool shit, but like they export like all right, let's go to the United States. What is the United States' main export? Wow. Our biggest export was petroleum, medical instruments. Okay, I feel like maybe gene sequencing machines might be classified under medical instruments. We need to go to that harmonized system and see what. Yeah, see, okay, where can we find? Let's ask ChatGPT that actually. I want to know. Where's my mic? Oh yeah. So I've been reading about this harmonized system or whatever, which is used by the Trade Commission to like to classify products basically. And I'm curious, where do I find out how like a gene sequencing machine or a lot of these biotech things are classified? Because I want to know like PCR machines, gene sequencing machines, how are they classified? In terms of international trade. World Customs Organization. Many countries have official customs website. Instruments for physical or chemical analysis. Instruments for DNA analysis. So that's what I want to do. So I want to search for that. So let's look up DNA in the OES. Using optical. Huh. Okay. So wait, is that 90? Because wait, where are we reading this from? So this thing said no. Hold on. I gotta close some of this shit. That was interesting. I want to read that. So 90 is medical stuff. So this is the US. So is this 90? HS 9018. So we make wow. Oh wait, no, here you go. Okay, wait, no. So wait, the top imports. What is broadcasting equipment? What does that even mean? The United States exported 180 billion and imported 278 billion. I understand what a trade imbalance is, but that quantity, is that really? People talk all this game about California's economy, but in terms of exports, Texas is taking it, bro. Texas is taking it by more than double. They're beating everyone combined. No, they're probably not beating everyone combined. California's rich, but we import all our shit. We still make a ton of aircraft parts. That's interesting. Maybe something to get in on. I don't know. Maybe we lose it. Who knows? Let's go back. This is not about airplane parts. It's about chips. All right. A fundamental question that arises from the confluence of these policies is whether they add up to a greater whole that constitutes a substantially new approach to trade. Another key question is how the simultaneous pursuit of new restrictions on high-tech exports as well as historic levels of domestic support for advanced industries will affect close allies of the United States. The Biden administration is complementing renewed domestic industrial policy initiatives with new multilateral economic agreements, such as the Indo-Pacific Economic Framework for Prosperity. Dude, all of this stuff is such shit. You know, it's funny when you think about all these hotty-toddy important people in suits talking about guiding all this stuff with money. But then you got people like Projects in Flight in the Bay Area making semiconductors in his freaking garage. So it's like, I mean, like, this is the kind of thing where that just makes you laugh. IPF, which is IPEF, which has 14 members, including the U.S., is an expansive four-pillar arrangement that covers trade, supply chains, decarbonization and infrastructure, and fair economy issues such as anti-corruption and transparency. I mean, can you imagine being the asshole sitting in that room trying to recommend, guys, you know what? I think we should have four pillars, and they have to like argue about how they name them. You know, trade, supply chain. Should we really call it supply chain or should we call it supply link? I'm sure that kind of bullshit happened in this. Whatever. That's just my 2 cents on these initiatives. The supply chains pillar includes specific module. Yeah, exactly. Guys, I think we need to introduce a new module. And there's a proposal, and it's just bureaucrats, to identify critical sectors and goods. It is interesting, though, the broader context of China's always been sort of upfront about, yeah, it's not free trade. We're going to go in and tell them, guys, we need you to do this. But the U.S. is always sort of, but I mean, to compete, the U.S. needs to take a more like, I don't know, do they though? I mean, this is all a bunch of mumbo jumbo. I like the other article because it wasn't just a bunch of like, right, okay, here. This paper is 102. It evaluates the intersection of the U.S. high-tech industrial strategy and its emergent trade strategy, focusing on the IPEF. The second paper provides a deeper dive into the semiconductor ecosystem in Japan, China, South Korea, and Taiwan, and the United States. So we already read that one. Are the birds gone? I feel like the birds might be gone. Yeah. Oh, but they pooped over everything. God damn it. I just cleaned this thing today. Oh, God damn it. Honestly, do we even need to read this? Like, I feel like the cool part was understanding the supply chain, and the boring part is all the politics. Let's just skim through this and then I'm done. I'm going to go do something more interesting. Who gets the money? That's my question. Who gets the money and how is it decided? I just saw that Intel got like 8 billion. Lab to fab. That's cool. The thing about these programs is that hands, allocated by private industry is way better allocated than this thing where all of these people that they just nip it and they just take it and they suck it dry and nothing actually gets done. And I'm very skeptical of honestly, it's not an all or one thing though. Like or it's not it's more complicated than that. So another 11 billion is allocated for several commerce programs. National Semiconductor Technology Center, National Advanced Packaging Manufacturer Program, Manufacturing USA Semiconductor Institute, Microelectronics Metrology Research, an investment. What does this mean? The act includes an investment. What does that mean? The government is trading? I don't know what that even means. No, they're spending it. They're just spending it. They don't expect to recoup their investment. I don't think. Government funding is contingent on several factors. Yeah, it's specifically calling out China. Oh yeah, but it's. I mean, who are we really talking about here? The act bars funding recipients from using funds in other countries. North Korea, Russia, Iran. The thing is, we all know Intel's a donkey. You got goats and donkeys. We all know that. And Intel's a donkey. I hate how unopen source this is. I wish maybe before I speak, I should go do some research on like what they're saying and what they expect to actually get out of this. Like what do they expect to happen? Yeah, I wonder if Atomic applied for the CHIPS Act because I feel like they deserve to get some money. I mean, that's great to hear that TSMC, you know, I mean, that's awesome. The thing is, hearing this, you don't really know about all the plans for China. Uh, but yeah, I mean, it's cool that we're getting so many fabs, but it's like, yeah, I need to make a map of all of the fabs in the states. I want to do this. How do I do it again? I got to do this, right? Not like that, but like whatever. Fuck it. I think it's too small. IBM is making a fab. Oh, that's silly, man. Look at this. You can get an idea for corporate strategy. It's like if you're a big player, you know that you're going to get money because you're like sort of the only, you know, uh, I don't know. That's just silly, bro. They started up a place just so that they could friggin' get some money. What a bunch of malarkey, man. I hope they don't get it. I hope IBM doesn't get it. You're a donkey and no one cares about you. Freaking donkey. Can we look at some of these places? I mean, look, TSMC already. I thought TSMC's Arizona plant is already producing chips, right? I'm pretty sure that's true. Yeah, what are India's main exports and imports? Um. Oh, hey, hell yeah, I want to play this. Export the most coal briquettes. I'm gonna say China. They're 13th. Where's the United States? We're fourth. Who else? Who else exports coal? I'm guessing people with large land masses. What about Russia? China doesn't really export that much coal, I guess. I was gonna say Brazil, maybe. What a bumpkin pick from me. Who else exports coal? Coal exporter. Dude, I have no idea who exports coal. I don't have number 2 or number 1 yet. Oh, maybe Canada? Nah, there's no way. Canada has a lot of land, but they don't. What's Canada's GDP? Let's look at these countries. feel like I'm gonna say Canada. Stupid guess, but I just want to know. Australia. Australia's the coal guy. Oh, wow, we were just talking about Australia. I was gonna guess Indonesia, but I didn't. I'm stupid. I thought Indonesia would Indonesia exporting that much coal is kind of crazy actually. Oh, South Africa is number 5. Dude, I love this game, bro. Yes, I can do better. That was mid as hell. Wow. That's crazy. What were we going to look at? We were going to look at India. Dude, this is like become my favorite website. Diamonds? Wow. That's basically what they do. Diamonds and oil? Really advanced, guys. Rice. So there's a bunch of petroleum refineries there. Dude, come on, man. The hell? Oh, wait. That's not what I wanted. That's cool, though. I like that. But no, I just want to go to China. Okay, I think I'm back. My bad. I think I'm back now. I guess I'm dropping bits. I don't know. China's biggest exporter. See, look at that, man. Dude, it's not even comparable. India's economy is a joke. Like, as a global contributor to like that's what I'm saying is we need to start to make these bipartite graphs and compute this because there's just no way that they have. I don't know. Maybe if you take the diff, maybe if you see their growth, maybe they're growing a lot. But it's like compare petroleum, diamonds, and gold to broadcasting equipment, computers, and office machine parts. Like, what does this even mean? What is office machine parts? Anyways, it's just interesting. That's it. Oh yeah, what did they import? They imported. Let's go back. There we go. Look at they have a $200 billion trade deficit. Deficit is that the right word? I guess that's the word they say, but I don't know. They import hella coal. They import the diamonds, so they import and they export the diamonds. What are they even doing with those diamonds? They're making freaking jewelry. It's interesting. Well, what crops do they export? Presumably they. Oh, rice. So all this fertilizer is going into rice. Oh, and cotton. So textiles. So they're basically jewelry and textiles. Very superficial country. All they care about is looks over there. Oh, wait. That's cool. IBM and STM. Yeah, exactly. They're being India's lack of willingness to entertain serious concessions. That's it's like no one's going to take you seriously unless you can get something done. There's just no high tech going on, I guess. Yeah, Vietnam is great. I kind of want to go to Vietnam actually. I feel like that'd be fun, dude. They have a young population, I think. We should look at Southeast Asian population pyramids. Oh, Indonesia is considered an uncertain geopolitical agenda. I mean, it's I don't know anything about their politics, but it's very arrogant to assume they side with the West. Oh, silica is abundant in Java. Nickel. Oh, new polysilicon factory. Dude, Indonesia is sweet, bro. I want to go to Indonesia too. I mean, because we have Spain. I mean, we basically need to know. So there's Germany for polysilicon. We need to know all of the people that refine metallurgical silicon. We need to know all the people that mine the quartz. I don't know. I guess the thing that's driving me saying all that is just like the assumption that maybe somehow the facility in Spain gets compromised. Like if someone just freaking strikes that thing in the event of a just doing some basic war gaming. Like okay, say that whatever it's called, whatever that quartz facility gets bombed, Spruce Pine gets bombed. Um, I don't know. Wargaming is hard to do in your head. You really got to model it. Economic frameworks, dude. These people are such cringe lords, dude. There's just all these people, and this is their job. But none of them freaking stream. None of them build shit. They just talk to each other in private. That's why if I blow up, bro, I'm gonna be talking. I'm gonna be live streaming all these fancy parties so that so that what I say isn't just hidden behind closed doors. It's totally crazy, totally insane. Insane. There's thousands of people that just involved in all these organizations, and you have no idea what they're doing. Corruption presents another silly as hell. The Philippine market. Can we go to maps? So Vietnam, I mean, it's all in the Indo-Pacific, right? Like that's what we need to understand is that all of this is happening here. I mean, obviously raw materials from elsewhere, but like the important part is here. The thing is, I mean, we do have a number of fabs in the U.S., so it's here in the U.S. The Philippines. I totally forgot about Brunei. Wait, wait. I didn't even know this. Malaysia owns. Oh, I didn't even realize that they share an island. It's kind of interesting. Dude, I love Singapore, man. I love these tiny Venice-like economic hubs. These city states, basically. Oops. Yeah, see, that's the thing is, I bet Australia is a nice place because they probably do have a lot of minerals. New Zealand. I mean, basically they're just throwing stuff at the wall that's in the Indo-Pacific to try to see who's down to help out. Maybe I mean maybe it's just such a far cry to assume that the U.S. can just do this as long as we secure the minerals and materials. The thing is, I don't know. It all comes down to how well these guys can execute on getting money into the right hands, basically, because it's all about that. So, against the backdrop of increased tensions with China, the United States is reinvigorating industrial policy through the CHIPS and Science Act, building a new regional trade architecture with partner countries in the IPEF. With this two-part solution, the United States is working to strengthen its semiconductor supply chains at home and abroad through collaboration with partner countries. Commensurate with the pursuit of industrial policy is the increased infusion of national security into the economic and trade policy realm. One part of the securitization of trade policy relates primarily to inbound goods. One part of the securitization of trade policy relates to primarily to inbound goods that constitutes critical parts of the supply chain, ranging from medical devices to downstream consumer goods such as smartphones. The other major security concern relates to outbound items, particularly exports of dual-use goods with both military and civilian uses. This language is something that doesn't jive well with me. I mean, but say you add a couple more quartz mines, why not just hit those as well? So you could just beef up the security at Spruce Pine and put an anti-aircraft missile on it or something. I don't know. If you do that, then maybe you don't need another mine. I mean, the thing is, none of this is going towards. I mean, it just depends on where can we see where these grants are being made. It's in the CHIPS Act Program Office. So, CHIPS Act Program Office. So these guys probably have a news, right? NIST. That's what I'm talking about. Chips for America. So funding updates. That's what I want to know. Okay, cool. This is exactly what we were looking for. So red is awards, but what are the awards? Foops. What are foops? Oh, really? That's funny. It's just I remember we were talking about this earlier in the stream. I was like, I wonder how they package these things. It's this. It's that. That's so silly. That's in Colorado. So look, these are pretty small awards. I mean, 75 million, it's a lot of money, but it's like, and then you look, and then you get this freaking Intel, and it's like, all right, we're obligatory going to give a donkey a bunch of money and see if they're able to do anything with it. Obviously, they won't be able to do anything with it, but everyone already knows that. But we have to give it to them anyways. Freaking donkey of a company. Dude, when has Intel done anything cool in the last freaking bunch of donkeys, if you ask me? For packaging. So we're making a packaging facility. Yeah, you wonder if the age of you wonder if the age of capitalism actually comes to a close. I mean, you'd hope not, but it's like it is interesting that policy is shifting to this more of like the government as a private equity fund or a VC trying to like make sure that they can win the war. Feels like a new era. These are proposed funding. These are the awards, but oh, here's the awards. Let's read all of the awards. What money has already been given out? It's crazy. It's like 75, 75. And then Intel, oh my god, dude. They've just given it all to Intel. It's such a joke. Hey, Rocket Lab got some. Space grade solar cells. That's cool, man. That's cool. So Global Foundries is going to make is there anything on lithography? Let's control F for lithography. Nothing. Oh, here you go. EUV. No, but see, this is stupid. This is just Intel using a lithography thing. Oh, TSMC got money? Okay. I mean, it makes sense. It makes sense. 5 million. I mean, these. It's so funny because it's like, how much time do you think? Like, okay, so this is $300,000. Take $300,000 versus $8 billion. Do you think that an appropriate amount of? Do you think like a linear amount of work was done to make sure that Intel was vetted? Hey, Santa Clara. I feel like this is all who you know too. I mean, look, these $300,000 little grants compared to the freaking 6.6 billion for TSMC and I guess something somewhere on the order of that much for Intel. Anyways, that's kind of all I got is like a general look at the supply chain of semiconductors around the world. We looked at trade data. We uh, we found some donkeys, that's for sure. Anyways, I feel like this is going to be a fun one looking back